Okay, good afternoon, everybody, or good evening. I'm authoring the paper with my colleague Ghada Refaat, and here in this paper, we want to go deeper in time series analysis because time series analysis is very important, but in this paper, we argue that text mining or getting insights from text analysis can improve the modeling of time series analysis. The research motivation, we focused on food price predictions and food security because, it is a volatile market and food is volatile due to different factors like, for example, logistics and transportations and global economy disruptions. So food security is very important. And of course, when it comes to essential things like food for the human being, it is important to study the phenomenon. We argue that the traditional modeling lacks signals from text, and this text comes from, for example, news sharing, social media post studies, experts' insights, reports. So we need to get insights and signals from these texts and try to combine it in the time series analysis. And here comes the semantic approach. The semantic approach is that we want to understand why, what are the factors. This is the semantic part. As I said, that the traditional methods, they lack the insights from text. We cannot generalize it because there are a lot of factors, and these factors we didn't take it into consideration. And this is the reason why the multimodal modeling is very important, the multimodal approach. When we wanted to do this review papers, we gathered literature from well-known research organizations like, for example, Elsevier, Springer, Sage, Science Direct. And then after collecting the papers that focused on time series analysis and food price predictions and combining text with these models. After collecting the data, we did an AI approach in analysis. We didn't go through the analysis ourselves. We made use of the new technologies like ChatGPT, like Gemini, and we produced for each paper a summary. So we went after the literature review, we did an AI approach with summarization. And then after doing the summarizations, I come from the background of IT. I started doing the word embeddings. The word embeddings is a kind of giving to each character and each word a number. And this number is taking into consideration the context and the position of the word within the sentence. This word embeddings helped us because after we did the summary and we produced the numerical word embedding representation of the summary, we did a clustering. We tried to find groupings in the subjects that were that came up in the summaries. And after this groupings, the groupings gets all similar topics together. We went again to the AI tools and we started to find labeling or title generation for these groups, for these clusters. This was our approach. We preferred doing this instead of doing the analysis, the review ourselves. The titles that came up with us were these. The predicting food prices using LSTM. LSTM is a neural network. So this came as a title. Predicting daily retail prices. The daily retail prices were important. Agricultural future prices. prediction was also an important topic, the futures markets and future prices, sentiment effect and sentiment analysis and sentiment intensity index, using the sentiment analysis to combine the text, the impact of the text on the time series, numerical time series analysis. Latent, the LDA is a topic modeling approach, was used as well, and especially in feature selection, because the LDA approach tries to get what are the keywords, what are the buzzwords found in the text, and these were the feature selection for the parameters, the missing parameters that we are not aware of in the time series analysis. Using, they were interested in food exports as well, by tweets, how the tweets and the sentiment in the tweets and the intentions in the tweets affect the food exports, and combining neural network prediction models. I will go further in the later in the other slides about this neural network, combining the neural network. Interesting, in in our analysis, we found that the literature with the time series and the food security, they differ a little bit. So we separated both of them. We separated the time series food price prediction from the food security analysis, and the food security, we came up with other titles, like the food security was more general about the phenomenon rather than the time series analysis. And the phenomenon is very important in policy analysis and trying to define a policy. They were interested in machine learning and classification models for policy analysis. They were interested in the lag in publishing the inflation rates and how web scraping can help in that. They were interested in food inflation a lot, and now costing. They were very interested in validation of food security. What are the food security indicators that we are going to follow? Sentiment analysis came along as well in food security, and a little bit with GIS and remote sensing and vegetation index, and how to make use of the GIS satellite images. So I can say that LSTM, which is a neural network, long-term, short-term neural network, is very important, and we expect that it will be the future, especially when it comes to things, volatile markets. Using regressions and auto-regressions is important as well, but LSTM for volatile markets and short and medium term prediction is very important. Trying to combine statistical models with neural networks is important as well, and we found a lot about hybrid models in the papers. Sentiment analysis was also came up a lot, and it is the gateway between the text and the quantitative models, because the sentiment is in a way quantitative. So trying to transform the text, seeing the sentiment of the text in a scale from -1 to 1 will convert the text into numerical representation and can be combined easily with the time series analysis. By LSTM is also came up as a good way to do sentiment analysis for food security. Our futures market came a lot of, because it is in investments, and they really wanted to know to make this the investment successful, and the text sources were news, tweets, investor search trends. Topic modeling, as I said, as it came in the charts, is important in feature selection, trying to reveal the uncovered, the missing values that we are not aware of, and we cannot just think of it like we have to go to the insights that came from the text that will highlight new features. Bird topics as well, they were very, we think bird topic is going to be used with the time series analysis. I think I came back. The study spanned China, South Korea, Indonesia, and Japan, and the commodities included pork, corn, soybean, and the textual data came from news, Weibo. Baidu Weibo is something like Twitter in China, and Baidu is something like Baidu is a search engine. And they use Twitter as well. Multimodal models integrates the statistical modeling with the stochastic modeling and the mathematical background with the neural networks and with the sentiment analysis. These were our insights that came from the analysis. Crop yield and land mapping came up with the food security, crisis management, and policy analysis as response to any disruptions in the markets came up as well. And this can be handled through predictions. If we can predict the things, sentiment analysis, inflation and price volatility. Well, here comes a little bit some technical terms like support vector machine in classification for food security, Bayesian classifiers, random forest for classification as well, the gradient boost as well, the k-means for the clustering. These are the machine learning topics that were heavily used with food security. And then came the large language models like BERT and BERT topic as well. They are used to convert the text to word embeddings and word embeddings to indicators. And integration of healthcare data. Healthcare data was so important with food security.
I need to interrupt you, Ghada. If you could just wind up in about half a minute, we'll appreciate that.
Yes, sure. So after we did this analysis, we went to the titles that we generated for each cluster, as I mentioned before, and then we went in the papers, the whole papers. And as I come from the IT background, we counted the repetition of these nouns that came in the titles that were generated for the clusters, and we divided this by the number of words in the research paper that they appeared in. So these they gave us a standard weight. The standard weight were the sentiment intensity and sentiment index. These were very important for food price time series analysis, long and short-term neural networks, investor concern. Investor concern has a high weight as well, retail prices, the topic modeling, the LDA, futures market, neural network, and BERT, the LLM. For the food security, the highest standard weight came for inflation and now costing, and then the crop and the health indicators. Opinion analysis was very important in crisis management. The classification models that I mentioned before with the different machine learning algorithms. Sentiment analysis came here again, but not that high like the other factors, and the vegetation index with the with the GIS and remote sensing images. These are the outcomes, and these are the results of the study.
Thank you so much.